Hello everyone, let's continue chapter 16, which is respiratory system. We're going to start with a couple of terminology. What is hypoxemia? If the pressure of oxygen inside the blood goes down, that is called hypoxemia. However, the word hypoxia is when there is not enough oxygen in the specific tissue or organ. For instance, if your heart is not getting enough oxygen, we call it hypoxia. You may have enough oxygen in the blood, but your heart is not getting enough oxygen. Why? Maybe there's a clot. So there is enough oxygen inside the blood circulation, but this oxygen cannot get to your heart because we have clot. So we may have hypoxia without hypoxemia. If you have hypoxemia, definitely you're going to have hypoxia, because if the pressure of oxygen inside the blood is low, then definitely you're going to have hypoxia also. But hypoxia may happen without hypoxemia. So I want you to know this one. Now, after knowing those terminology, let's start with the Boyle's law. You already know this one also. The pressure of gases depends on the volume. When the volume decreases, like in this case, then the pressure is going to increase. The pressure of gas is going to come based on the number of the contact between this molecule. If you decrease the volume, the chance that this molecule is going to hit each other, contact each other, will increase. So therefore, if the volume goes down, the pressure is going to go up, and vice versa. That is called Boyle's law. We mentioned this one in the previous discussion. We said when the size of your lung increases, the pressure inside the lung is going to go down. As a result, air is going to come from outside to inside the lung, because air is going to go from higher pressure to lower pressure. The next topic that you need to know is about partial pressure of gas. What is a partial pressure of gas? What is the pressure in this room? The pressure of this room is 760 milliliter of mercury. Where this 760 is coming from? Inside this room, we have many different gases. Nitrogen, oxygen, CO2, vapor of the water. When you add the pressure of each gas, the total amount will be 760. So therefore, I would say the atmospheric pressure in this room is a combination of the pressure of each of these gases. The pressure of each gas is considered as a partial pressure. So partial pressure is a pressure that each gas creates in the mixture of gases. So the pressure of nitrogen is called partial pressure of nitrogen. The pressure of oxygen is called partial pressure of oxygen, and so on and so forth. Together would be 760. This idea that the total pressure, it comes from the combination of the different partial pressure, is being explained by Dalton. So that is called a Dalton law. Now the question is, how much of this 760 comes from nitrogen? And how much of this 760 comes from oxygen, and so on and so forth? Well, the answer is the pressure of nitrogen depends on the percentage of nitrogen. How many percent of the gas in this room is nitrogen? I hope you know that 78% of our gas in the space is nitrogen. If 78% of my gas is nitrogen, then 70% of this pressure should come from nitrogen. PiN2 is a partial pressure of inspired nitrogen. If 78% of my air is nitrogen and the pressure of the air is 760, therefore the pressure of nitrogen, the partial pressure of nitrogen will be 600. In other words, 600 out of 760 comes from nitrogen. With the same token, for oxygen, the partial pressure of inspired oxygen is the percentage of oxygen, fraction of oxygen, times the atmospheric pressure. How many percent is oxygen? 21%. The total pressure is 760. So then the total pressure that comes from the oxygen is 160. As you can see in this table, 78% of our inspired air is nitrogen, 21% is oxygen. The amount of CO2 in this air is very low, it's around 0.3%, very small. And the water vapor will be variable. It depends if you're living in Maryland or you're living in Texas. When you breathe this air in, you're breathing air from the outside. And this air is going to get inside your respiratory system. I'm sure you remember that one of the functions of respiratory system is moisturizing the air. Your respiratory system is going to make sure your air is not dry. Your respiratory system is going to add water to the air. And the amount of pressure is equal to 47 millimeters of mercury. So remember, the total pressure is 760, and now 47 millimeter of mercury comes from the water. So therefore, the share of other gases is going to go down. Let me explain what I mean by that. If I have $100 in my hand and I'm supposed to give it to 4 people, each one is going to get $25. If I add the share of one person, if one person is going to get 50, then the share of other people is going to go down. Now I have only $50 to divide between 3 people. When you breathe this air in, the pressure of the air is always 760. If I add water to it and the pressure of this water is 47, that means the partial pressure of each gas is going to go down, because now instead of 760, I have to subtract 47, which is for the water, and the rest will be divided between the rest of these gases. Let's take a look at an example. We said 21% of the gas is oxygen. When you breathe this air in, the pressure is 760, but we said 47 belongs to water. So now the total pressure here is not 760 anymore, but is 760 minus 47, because again, $47 goes to one person, then the rest of this money is going to be divided between other people. So if 47 millimeter of mercury is from water, then the rest of this pressure, which is 713, is going to be divided between other gases. So now we have to say 21% of the 713 is the partial pressure of oxygen. So therefore, that's going to be 149. So realize that inside the air, the pressure of oxygen is 160, but when you breathe in, the pressure of oxygen is going to drop, because part of this pressure goes to the water and the rest will be divided between other gases. So therefore, in this picture, you can see the pressure of oxygen is 160. When you breathe air in, the pressure of the oxygen inside the airway is going to drop to 149. For simplicity, we say 150. Now you understand why it's going to drop, because now you're adding water to it. And water is going to take some share, and the share of other gases is going to drop. Now, when this air is going to get inside the alveolus, this is alveolus, as you can see, the pressure of oxygen is going to drop further. It's going to go to around 100 or 105. Why is it going to drop even more? What happens here between the airway to the alveolus that pressure is going to drop more? Well, the answer is, remember, blood is going to come from pulmonary artery. Pulmonary artery is going to bring blood without oxygen, and you bring this blood here to exchange to get CO2 out and bring oxygen in. So this is a pulmonary artery. After oxygenation, blood is going to go through pulmonary vein. So this is a pulmonary vein. And you remember that pulmonary vein is going to drain finally to the left atrium. So blood is going to go through pulmonary artery to the lung. Lung is going to make oxygenation, and this blood with oxygen is going to come back to the left atrium. This red line represents pulmonary vein, and this one is pulmonary artery. Therefore, this is my pulmonary artery. After air is going to get exchanged, it's going to go to pulmonary vein, and this one is going to end up to the left atrium, and left atrium is going to send blood to the left ventricle, and ventricle is going to send it to the aorta. The pressure of the oxygen inside the venous blood is around 40. The pressure of CO2 in the venous blood is around 47. Blood is going to come and exchange, oxygen is going to come in, and oxygen is going to get inside the blood. So pressure of oxygen is going to change to around 98 or 100. The pressure of CO2 is going to drop around 40. Realize the pressure of CO2 inside the alveolus and pressure of CO2 inside the arterial blood is going to be the same after exchange. Now the question is, why this pressure of oxygen from 150 is going to drop to 100 or 105? Well, the answer is, remember, the amount of CO2 inside this air is almost zero. But the amount of CO2 inside the alveolus is going to be 40 because you're exchanging CO2. When the share of one gas goes up, the share of other gases is going to go down. If now CO2 is going to claim more share, now the pressure of oxygen is going to drop from 150 to lower. That's why it's going to go down. This is really important that you understand. This blood, when it leaves the alveolus, has a pressure around 98 to 100. It's slightly less than the pressure inside the alveolus. Why? Because probably diffusion is not perfect here. So it's not going to be a perfect diffusion. It's going to be very close, but not exact the same. However, when this blood from pulmonary vein gets to the left atrium, then the pressure is going to drop even lower. Why? You don't need to know exact detail of this one, but I'm going to show you why the pressure is going to drop. I'm trying to tell you that here's your heart and this is your lung. When the blood comes from the lung to the left atrium, the pressure of oxygen inside the lung is around 100, but the pressure of oxygen inside the left atrium is around 95. Why is it going to drop? Well, the answer is some blood, without going to the lung and get the oxygen, is going to drain inside the left atrium. Some venous blood, remember vein has low oxygen, and this blood of the vein should go to the lung and get oxygen. Some veins, without going to the lung, without getting oxygen, they're going to drain inside the left atrium. That is not cool because blood comes from the lung with high oxygen. It's going to get mixed with the blood with low oxygen, and as a result, PaO2 inside the left atrium is going to drop from 100 to 95. You don't need to know detail why this one happens and which veins are those, but I want you to know that around 2% of my cardiac output, instead of going to the lung and get the oxygen, directly is going to get inside the left atrium. Therefore, blood that comes from the lung is going to get mixed with the blood that comes from those veins, and as a result, the pressure of oxygen is going to drop lower. So do you see why the pressure inside the alveolus here is around 100 or 105, but here is inside the artery, systemic arteries around 95? Again, because there is some mixture of the venous blood with blood comes from lung. Another interesting point here is this. We mentioned that when the PaCO2 goes up, then PaO2 is going to go down. You remember in the previous recording, we talked about alveolar ventilation equation. The idea was this, that if you ventilate higher, if you expire the air out, then your PaCO2, the CO2 inside the alveolus, capital A, is going to go down. If you hold your breath, if you don't ventilate, then PaCO2 is going to go up. We learned this one. Now I want to talk about alveolar gas equation. What is alveolar gas equation? In this equation, we want to find out if your PaCO2 goes up or down, if the amount of CO2 inside the alveolus goes up and down, how your oxygen is going to change. That is called alveolar gas equation. If this PaCO2, which is around 40, change to 60 or 70 or 80, how your PaO2 is going to change? Or if the PaO2 is going to go from 40 to 30 and 20, how your PaO2 is going to change? We already know that. We said when the share of CO2 goes up, the share of oxygen is going to go down. When the share of CO2 goes down, the share of oxygen is going to go up. But how much? Well, that can be explained by this formula. It's called alveolar gas equation. The equation is right here. The pressure of oxygen inside the alveolus is equal to the partial pressure of inspired oxygen, PiO2, minus the pressure of CO2 inside the alveolus divided by R plus correction factor. I don't want you worried about correction factor. For your class, we're going to ignore this one. So simply, this formula is going to change into PaO2 is equal to PiO2 minus PaCO2 divided by R. What is R? R is respiratory exchange ratio. Normally is around 0.8. Sometimes, for simplicity, we're going to change it to 1, but is not 1, is 0.8. So for now, I want to consider 0.8 because that's a right exchange ratio. So this is a formula. What does that mean? What does it tell you? Let's put a number to find out what it means. If I want to measure PaO2, we said the formula is PiO2 minus PaCO2 divided by R. What was my PiO2? My PiO2, we said, is equal to FO2, the fractional oxygen, times atmospheric pressure minus the pressure of water, if you remember. This one was 760, this one was 47, this one was 21%. So therefore, we said PiO2 is equal to 149. So PiO2 is 149. We already measured this one. So now I'm going to say PaO2 is equal to 149. PaCO2 is normally 40 divided by R, which is 0.8. Therefore, 40 divided by 0.8 would be 50. Here's 149. Therefore, my PaO2 would be around 99 or almost 100. That's why you can see here PaO2 is around 100, more or less. Now, here's an important point that I want you to understand. If I hyperventilate, that means I'm going to decrease my PaCO2. Then I have to expect my PaO2 is going to go up. But how much? Well, the answer is, since the formula shows PaCO2 divided by 0.8, that means if I increase my ventilation by twice, in other words, if I ventilate 2 times more, my PaCO2 is going to change to 20. But my PaO2 is going to increase more than twice. Why? Because I have to divide this PaCO2 by 0.8, not by 1, but 0.8. As a result, if you hyperventilate and decrease your PaCO2 by half, your PaO2 is going to increase more than twice. If you stop ventilating and your PaCO2 is going to increase by 2, is going to change from 40 to 80, your PaO2 is going to drop more than half. So it's not exact relationship. The PaO2 is going to increase or decrease more than the change of PaCO2. Another important fact about this picture is this. As you can see, normally the difference between PaO2 and PaO2 inside the artery, the difference between these two should not be more than 10. As a matter of fact, it's somewhere between 10 to 15. If the difference between the pressure of oxygen inside the alveolus and pressure of oxygen inside the systemic blood is more than 30, definitely is abnormal. We show it as PaO2 minus PaO2 should be around 10 to 15 millimeter of mercury. If this one goes 30 or above, there's something definitely wrong. If the difference is higher than 30, that means something happens and prevent a good oxygenation here. You'll learn later in the clinic what you have to expect, but here I want you to understand that the difference between PaO2 and PaO2, between alveolus and artery, should not be more than 10 to 15. Definitely anything above 30 is abnormal. Can I measure this one? Yes, I can get a sample from the artery and find out the PaO2 in the blood, in the artery. Can I measure this one? Yes, I can. I can measure my PaO2. If I have my PaCO2, I can measure this one. How can I measure my PaCO2? Do you remember I said PaCO2? The pressure of CO2 inside the alveolus is the same as pressure inside the artery. So if I get the pressure of the CO2 inside the artery, I can measure the PaCO2. And if I measure my PaCO2, I can measure my PaO2. Let's take a look at an example on this one. Let's say you have a patient that comes with lethargy and confusion. And this patient has a type 2 diabetes. When we do a blood test on this patient, we're going to get PaO2, the pressure of oxygen of 90 millimeters of mercury inside the artery. We can measure this one. We can measure the CO2 inside the artery, which is 19. And the question tells you if the respiratory exchange ratio is 1, remember normally is 0.8. What would be A minus A? What is the difference between the pressure of oxygen inside the alveolus minus pressure of oxygen inside the artery? We already have the artery is 90. Before even we go and answer this question, I want you to look at this number. As you can see, PaCO2 usually is 40, but now it's changed to 19. That means is decreased. When the PaCO2 decreases, what do you expect is going to happen to PaO2? We said when the PaCO2 goes down, remember PaCO2 lowercase is equal to PaCO2 uppercase. Pressure of the CO2 here and the pressure of CO2 here must be the same. So therefore, if this one is 19, this must be also 19. And if this one, we said, drops, then PaO2 should go up. So we already know it's going to go up. But how much is going to go up? Let's take a look. We can measure this one. So the formula was PaO2 is equal to PiO2 minus PaCO2 divided by R. We know that PaO2 is 90, and we know that PaCO2 is 19. We got this one through the blood test. So first, let's measure PiO2. PiO2 is equal to fraction of oxygen times atmospheric pressure minus pressure of oxygen. We said this one is 760, this one is 47, and this one is 21%. So therefore PiO2 we said is equal to 149 millimeters of mercury. So I have my PiO2. So I'm going to say 149 minus PaCO2 is equal to this one, so it's going to be 19 divided by R. We said in this example is 1, so it's going to be PaO2 is equal to 149 minus 19, and it's 130. So the pressure of the oxygen inside the alveolus is 130 instead of being normally 105 or 100. So as you can see, now we measured PaO2. Now, after we measure PaO2, we want to see the difference between this one and this one. We said in the lab result, this one came back as 90. So therefore, we have 130, and here we have 90. The difference between 130 and 90 is 40. So as you can see, there is a big difference between these two. That is abnormal. There is something wrong with this patient. Let me tell you something that probably you already know. Let's say this is the heart, and this is your lung. And we said blood is going to come to the lung and get oxygen is going to come back to the left atrium. The pressure of oxygen inside the lung, we said, is around 100. And the pressure inside the left atrium, we said, is around, let's say, 95. If I want to increase the pressure of the oxygen inside the artery of this patient, let's say a patient comes and the pressure of the oxygen inside the artery is 80. I want to increase it up. What can I do for this patient? Well, you may think about two ways to do it. One is, remember the percentage of oxygen is only 21%? We can put a mask in the patient's face and increase it from 21% to 50%. If I increase this percentage of oxygen to 50%, obviously my PiO2 is going to go up. That's one way. Increase the percentage of oxygen. Or, remember the pressure of the air here is 760? Well, put the mask on the patient's face and increase the pressure. Let's make it increase to 1,000. If I increase it to 1,000, also my PiO2 is going to go up. Because after all, remember, PiO2 is equal to a fraction of oxygen times atmospheric pressure. If I increase the fraction of oxygen from 21% to 50%, my PiO2 is going to go up. If I increase my atmospheric pressure from 760 to 1,000, my PiO2 is going to go up. So if I want to increase the pressure of the oxygen inside the artery, either I have to increase the percentage, or I have to increase the pressure, or I can do both. That is going to help this patient to increase the oxygen inside the blood. So knowing that one, let's take a look at this example. So let's say you're bringing a patient to the hospital where the pressure outside is 500 millimeters of mercury instead of 760. You may say, how is it possible? I would say, let's say you're living in a very high altitude. If you're living in a very high altitude, the pressure of the air is going to drop, obviously. So let's say the pressure of the air is around 500 millimeters of mercury. And when you do tests on this patient, you can figure out that PaCO2 is around 80. And if respiratory exchange is 1, you want to bring the PaO2 of this patient to 100 millimeters of mercury. So if I want to increase PaO2 in this pressure, without increasing the pressure, what percent of oxygen I have to give to this patient? So let me make sure you understand the question. The question is, the pressure of the air is 500. I want this person to have the pressure of oxygen around 100 millimeters of mercury inside the alveolus. To do so, I have to increase the percentage of oxygen. What percent of oxygen I have to give to this patient to make sure PaO2 is 100? Because remember, if I give 21% of the oxygen, then the PaO2 will be much lower. Let's take a look. If you remember this formula, PaO2 is equal to FO2 times atmospheric pressure minus pressure of water. If this is 500 and this is 47, and if it's 21%, then my PiO2 would be 95 milliliter of mercury. And if my PiO2 is 95, then my PaO2 would be 95 minus PaCO2 divided by R, which is 1. In the example, they said PaCO2 is 80. So therefore, it's going to be 95 minus 80 is going to be 15. The PaO2 would be very low. I want my PaO2 to be 100. So I have to increase my fraction of oxygen. I have to increase the percentage of oxygen. How am I going to do it? Well, the answer is, the formula was PaO2 is equal to PiO2 minus PaCO2 divided by R. I want this one to be 100, correct? So what my PiO2 must be if I know my PiO2 is 80 and my R based on the question is 1. So therefore 100 is equal to minus 80. So I want my PiO2 to be 180. PiO2 we said is equal to FO2 times atmospheric pressure minus the pressure of water. We said this one is going to be 180. So what is my Fi2 would be if my atmospheric pressure is 500 minus 47. This one is going to be 453. So therefore times Fi2, 180. So therefore it's going to be my FO2 should be around 40%. If I give an oxygen through the mask with the 40% of oxygen, then as a result my PiO2 would be 180. When my PiO2 is 180, my PaO2 would be 100. So do you see that in the hospital, to make sure the patient is going to get the right amount of oxygen, you can calculate how many percent of oxygen you're going to give to the patient to create a right pressure of oxygen.